Get busy! Where facts don't care about your feelings. Alright, so what are we doing today? Well, we are going to continue our discussion on galaxies. Great to see everybody. Now, just to recap on what we were talking about last time. Scott, we were talking about supermassive black holes as opposed to supermassive assholes. Now, just to show you what I'm doing, we're going to make coffee halfway through this peripilo. So have a, oh, excuse me. Here is our coffee with the sugar. AZ Mum! And here's our pear, here's our rice pudding. Here are the strawberries. I've already eaten 2 of the strawberries. I couldn't wait for you, sorry. All right, so that's what we're going to do. So we're going to talk about the supermassive black holes, including my mouth for the strawberry. Alrighty. So we spoke about the black holes in the last lecture, which are about up to 1 billion times the mass of the sun, but they're so compressed in size that when other stars orbit those black holes, as they get close to what looks like nothing to us, they just go as they fly around the corner, like blinding speeds. And then, so the other thing we wanted to talk about was dark matter. You could call it ghost matter if you want. I mean, it doesn't make a difference really. It is, no one knows what the hell it is, but there is so much mass of dark matter that it actually stops the galaxies from getting blown apart. So if it wasn't for that, we'd just blow out into space. Hey. And gravitational lensing. We spoke about that because space-time itself is getting bent. And that is why light looks like it gets bent. Because how can you bend a ghost, right? If light is has no mass. You bend space-time all the way around it. Oh. All right. Clusters of galaxies. We spoke about the rich clusters, which tend to be condensed around a large central galaxy, 1,000 or more galaxies. Can you believe that? They talk about galaxies in thousands. You know, it's like there's thousands of galaxies here. Poor clusters, when you have less than 1,000, often just a few. And they're not generally condensed towards the center. So it's probably like they just happen to be hanging around. Would a black hole be bad for Earth? It depends on how much you hate the Earth. Hold on, let me put the light on. Why isn't the air conditioning working? It is like 100 degrees in here. I'm not even joking. Today it's 100 degrees and it's spring, the 3rd week of spring, and it's 100 degrees. What is that? Oh, I know why I can't see myself, because the freaking brightness is almost on 0. Oh, now I can see what's going on. All right, so let us continue with our rice pudding. Oh, that coffee smells good. I haven't even made it yet. But when we get halfway, we will then make the coffee to celebrate. So that rice pudding has the beautiful cinnamon on top with a little bit of pistachio. Oh, it's too good. My dad made it. So as I said before, we have our galaxy cluster with a local group. So I've just woken up, so neighboring galaxies. The local group, we've got in here the Andromeda Galaxy, which is just outside, but that's slowly coming in and it's going to collide with us. And then we've got the Small Magellanic Cloud and the large Magellanic Cloud, so LMC and the SMC. SMC is gap smacked. Milky Way, that is us in the center, so because we think everything revolves around us. It's fall where I live. Yeah, I can imagine. Fall, so you're in America. Because I think in Canada they call it autumn, just like we do, right? So there, our galaxy's in the center, and I'm not giving you guys the finger, forgive me. That is our local globe. Andromeda's right on the outside, and then there's our local galaxies. USA! Excuse me. Now we're going to talk about neighboring galaxies, and I'm just going to have another bite of the rice pudding. That's what we're going to talk about next. Oh, that's good. All right, now let's talk about what's going on next. Is this an okay shot, or is the light not working very well with you guys? I'm trying to... Oh, that's my granddad back there. That's good. There's a handsome fella. Yeah, I should have my book in the background from now on. I should learn from like marketing people. All right, so neighboring galaxies. Some galaxies of our local group are difficult to observe because they are located behind the center of our Milky Way. So because visible light is getting obstructed by all of the dust and everything else. Excuse me. All right, so now we're going to look at the Canis major galaxy, Canis Major. You can also call it the Canis Major. If you have a look, you'll notice. See, it's called the Canis Major Galaxy, but I don't know why my brain always says the Canis Major Galaxy. I'm not sure why, but the Canis Major Dwarf Galaxy has orbited around the Milky Way a number of times. Can you believe that? It's actually gone around the Milky Way, and tidal forces has ripped away stars and gas. So we're actually ripping stuff away from the Canis, which is pretty phenomenal. And that's even without a black hole. I know it's probably our hole that's ripping away the Canis. All right. Interacting galaxies is another one. Particularly in rich clusters, galaxies can collide and interact. Galaxy collisions can produce ring galaxies and tidal tails. Folk music, welcome back, my friend. Often triggering active star formation, starburst galaxies. So starburst galaxies, you know, starburst like the lolly. I don't know what you call them, sweets or bonbons or whatever you guys call them over in the US. But basically, you tell everyone. That's awesome that you know everyone. I love that. All right. I want to hear some folk music, man. All right. So rich galaxies can collide and interact. Galaxies can produce ring galaxies and tidal tails. So that one's pretty amazing. If you have a look right there, you can see a ring galaxy. So it's a galaxy that's like a whole ring. Everyone squared minus one. Very good. Very quick. Awesome. Often triggering. So there you go. Active star formation gets triggered. This might be the smartest man on Periscope. I don't know if that's saying much if you've seen Periscope. With the Milky Way in the very far future. That's so true. Very true. You know, it's funny. In terms of the life of the universe, it's not that far. You think I'm smart? I can prove you wrong. Blah, 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 blah. There you go. All right. So, tidal tails. Example for galaxy interaction with tidal tails. The mice computer simulations produce similar structures. That's actually quite amazing that you can use computers, plug in mathematical equations, and it recreates exactly what we see in real life. And that you know the chance of that is like zero, right? Like if it wasn't close. If the mathematics wasn't close, right? Like when I mean close, I mean to like the millionth of a degree close, right? If it wasn't that close, then we would not get anything like what we see in space in the simulations, right? So in the future, they might even be able to run a simulation that could recreate you, you know, like your consciousness could be recreated. And then when people talk to it, it would say what you would have said. The G-host. And the ghost G-host. Yeah. But that's quite phenomenal, right? Look at this. That is what happens in real life. I'm too high all the time. Well, what we'll do is we'll recreate you and then put the recreation on marijuana. Your formula could we have planets outside the solar system that come into our solar system? Ooh, good question. Yes, that happens all the time, but they won't make it into here because Jupiter will rip them apart with its gravity. That's why between Mars and Jupiter there's a whole asteroid belt, because the planet can't form there because of the gravitational tidal waves. S.P.G host, you know the stilo, your girlfriend's looking in the pee hole. Interesting. It's I guess that helps as to why I'm the smartest guy on Periscope. It's told you it's not a high bar. All right, so this is what's actually happening, and this is what the mathematical models are producing. And what you can see is that's a clean, high-resolution version of this. Now, what is the odds of that, right? That's just insane, because you could have had anything. Could have just made a blob or whatever, but it made the exact tidal tail. It's just phenomenal. Simulations of galaxy interactions. So if you have a look at this one, right, this is a mathematical model of two galaxies interacting, and that's exactly what the computer produced. And in the end, when the computer ran its course, it ended up like that, which happens to be exactly what we see in real life. So what is the chance of that happening, right? So that's basically 99.9999% chance what happened as to why the galaxies are like this. Some people think it was just God that made it that way. You never know. You never know. So now we're going to look at the mergers of galaxies, right? Mergers of galaxies. Hey, folk music invited everyone minus everyone less one. Probably a result of merger of two galaxies about 1 billion years ago. Small galaxy remnant is the center, is rotating backwards. It's insane. Multiple nuclei and giant elliptical galaxies. Yeah, so here we go. You can see that galaxy. Do you believe in a planet X or Nibiru? I don't work on belief, as I like to tell people, but there are hundreds of billions of planets. L. Brooks is back. Now, look, to be fair, linear algebra is not easy at all. If you're a Patreon member, man, just send me your stuff and I'll help you out. I'll solve some of the problems on Periscope for you. I don't even have the Patreon account yet, but once I do, become a Patreon member. And I'll answer the questions for you. All right, so here we go. Starburst galaxies. Okay, mergers of galaxies, right? So what happens here, right? You look at an elliptical galaxy. Now, an elliptical galaxy has multiple nuclei. Like, it has multiple centers. Now, why would it have multiple centers? That makes no sense. Unless you assume that that is made up of other galaxies which all collided, which is what's happening, as the wolf correctly said Andromeda will be doing with us. They are dancing and it's too good. That rice pudding is just too good. All right, now we have, there's a galaxy called M64, the central region living matter. Dan on Fleek is back. I don't know what you mean by living matter. Radio image M64, the central part of the galaxy is rotating backwards, but my people are stupid. They're probably all too high. Hey, Dan, welcome back. All right. All right, you can see that the center of this galaxy is rotating the wrong way, like basically like your other friends that you don't want to invite. they're like walking around somewhere. All right, starburst galaxies. Starburst galaxies are really fertile, right? Stars are getting born, pretty much. Stars are getting born at a very high rate, right? So there's a lot of action going on. Starburst galaxies contain many young stars and recent supernovae and are often very rich in gas and dust, bright in infrared, ultra-luminous infrared galaxies. So that means it's alive with energy. Ah, yeah, you could say that. That's a good way to look at it. So starburst galaxies, what's interesting is that they were saying there's a hypothesis that supernovae are what, the shockwaves are what create new new stars, right? And what's interesting is that when you find a galaxy, no way, oh man, you gotta tweet me some photos if you get anything good. That's awesome. All right, so what's interesting is that the galaxies that have heaps of new stars also have heaps of supernovae, so that's consistent with what we were saying about the hypothesis. All right. So interactions of galaxies with clusters. Now this bit is pretty awesome. So once we get to supermassive black holes, I'm going to stop and we're going to make coffee together. The Earth is living with energy. Yeah, it is, of course. In fact, the Earth has like the average level of the average energy density in space, right? Earth is like 30 billion or trillion, something like that, times the average energy density, right, that you expect in space. So we are such an unusual part of the universe. Having said that, the universe is so big that there's billions of places like here with planets and with rain, and we don't know if they have oxygen yet, but we'll find out in the next couple of years. I want to go to the magma core. That's because, Dan, my friend, you are, to use a pun, light years ahead. Which is why you have the telescope. When galaxies pass through the thin gas of their home cluster, their own gas can be almost completely stripped away. That's interesting. What does that mean? When galaxies pass through the thin gas of their home cluster, their own gas can be almost completely stripped away. When galaxies pass through the thin gas of their home cluster. So galaxies have a home cluster. Gotcha. That means that there's a cluster of stars hanging out, and they happen to be in our galaxy. And when our galaxy is moving, the cluster itself is sucking all of the gas away from its gravity. Got it. It's like a vacuum cleaner. All right, the next, farthest galaxies, the most distant galaxies visible by HST, which is the Hubble Space Telescope. Do you think that aliens exist? They don't have to be intelligent, but I would say the chance that, just any sort of life doesn't exist is, I would say, almost zero, but that's just speculation. But there's a reason for that. It's called, when you have an anomaly multiplied by infinity, it becomes a certainty. That's a statistical rule. Hey. And so if the universe is as infinite as we think, then the chance that we are not replicated, or at least the bacteria is not replicated, is almost zero, I would submit. I mean, they could even be on one of Jupiter's moons. We don't even know, because those places have like conditions for life. One of their moons is an ocean of water. There's no land, it's just water, like Waterworld, which is pretty awesome. How big is Uranus? I've given that joke before, but it's still funny. Sorry, man, that just came out of nowhere. It was good. The farthest galaxies. That joke never gets old, man. The most distant, how many thousands of kilometers is it? You went too far. Well, at least you use kilometers and not miles. The most distant galaxies visible by Hubble Space Telescope are seen at a time when the universe, the old ones are the best. That's so true. All right. Are seen at a time when the universe was only 1 billion years old. That's pretty awesome. So Hubble Space Telescope can see galaxies that were only 1 billion years old, right? So when we say only 1 billion, in other words, Hubble Space Telescope can look back 12 billion years, right? Because the light took 12 billion years to reach us. Yes, exactly. That is so true. That is so true. Yeah, they reckon they're going to be able to pinpoint oxygen. And if they can find oxygen on these planets, about the mistake they made with the Hubble lens. Yeah, I did. Yeah. Very fascinating stuff. Can you imagine after all that time they put it in space and then they can't see anything? It's amazing that they even got it into space. Like there's like millions of ways it could have gone wrong, right? It's going to have infrared. Yeah, that's right. Oops. Yeah, Ghost is dead on. I slightly touched on that in the last lecture, but that infrared they're going to use to detect if there's oxygen on other planets, which means that there'll probably be life. Wrong units of measurement. That's what it was, huh? Yeah. So because oxygen is highly unstable, so there's only really one way that you would see oxygen on an entire planet, and that's because there's life there. And it's like plant life, algae life, because they excrete oxygen, as you guys know, right? So if they find that, then that's like, yep, there's life on other planets, which is just insane. Insane. The most distant galaxies. All right. That's why we need to do away with the English system. Yeah, that's it. Bring on the metric now. Hubble did go wrong at the start. Nearsighted. Yeah, that's right. Nearsighted bastard. Metric rules. I know there might be a war over that. Here, so if you look, the ones with the arrows are the galaxies that are 12 billion light years away at the time. But space has spread so far now. Hey, it's spread that now that we've received the light, the galaxies now are about 90 billion light years away because space is expanding. From its grains, right? Inside each of the holes of the 4-dimension, seeping through is dark energy. All right, so we're going to take a break, and then we're going to talk about black holes and quasars and Seifert galaxies, radio galaxies, cosmic jets, which is going to be really good. But what we're going to do now is we're going to make the coffee together. I thought I would share that with you. You're mathematically computer generated. It all makes sense now. That's it. You know, there's a new show coming out on ABC called The Good Doctor. And I looked at it, I said, they stole my life. Cosmic coffee. Cosmic coffee! All right, we've got to do that next time. Cosmic coffee quoted by Dan on fleek. Dan is so on fleek, my friends. All right, let's do it. Dark energy is pushing the expansion. Absolutely, absolutely. But we don't know if, like here, we don't know if it's, all right, so now I'm going to boil the water. Born this way. You're just born on fleek, my friend. All right, so let's see if we can talk about some other galaxy stuff while I'm making the coffee. All right. So, active galaxies and supermassive black holes. Alrighty, let's do this. Alrighty, so active galaxies are extremely violent. They have energy release in the nuclei, which is heaps and heaps of nucleus. Active galactic nuclei is called AGN. Alright, so active galactic nuclei, AGN, up to many thousands times more luminous than the entire Milky Way. Energy released within a region approximately the size of our solar system. All right, that's insane. So basically, the nucleus of the galaxy, right, for an active galaxy, is like the size of our solar system, but I can see the Milky. You can see the Milky Way. Are you in the southern hemisphere? No way. So up to many thousands times more luminous. So that the nucleus of these galaxies, of the active galaxies, are so freaking active, like a teenage boy and girl, that it is brighter, thousands of times brighter than the whole Milky Way. Just the nucleus of this little thing, which is insane. All right, our thingamy is now boiled. So now what we're going to do is we're going to make the coffee. Are you guys ready? Let's make it together. All right, so now what we do is we get the boiling water and we pour it into here. Where's my spoon? Ah, shit, I forgot the spoon. All right, and then, then now what we do, you can smell it already, my friends. You can smell it already. Now I'm gonna get my long spoon, hey, and we ignite the gas. Alright, and now we stir this bugger, and then we wait for it to boil. Alrighty, so now here is our coffee as we're waiting for it to boil. Back to the hypnotist angle. Scott, always a pleasure. So now we're just going to stir the bastard. I wanted to get it off the bottom. Now you can see that beautiful at the top. I've got this thing here. Oh, that froth. That is so good. It's so pretty, isn't it? Oh, look at that. You can see it. It looks starting to look like a pudding at the top. I love that. Now it's starting to coalesce. You can see. And that means that the bottom is bubbling. Oh, there we go. That almost went right over the edge. Yeah, that's done. That is done, my friends. That is done. There you have it, our coffee, ladies and gentlemen. Abyss is back! There is our coffee. Now we can start with black holes. Chemistry at its finest. You know, now I get why you are down on fleek. You are so on fleek, my friend. You are completely and utterly on fleek. All right. Now we've got our coffee, so we can continue with this lecture. Oh yeah, we're back. I put on the air conditioning and it hasn't even turned on. I don't know what it's doing. Maybe someone's put it on heat. Let me just check. What's the bet that someone's freaking put it on heat? Oh, you gotta be kidding me. It was on heat the whole time. Bastards. Mode. There we go. I'm wondering, why am I dying? Alright, so it's 100 degrees today in spring. This is Sydney, 100 degrees in spring, man. It's just ridiculous. Alright, so we spoke, and I'm a doctor, but that's another story. Ah, there you go. There is much more to Mr. Fleek, to Dr. Fleek. That's it, Dr. Fleek now. Oh, look at that coffee. It just came out like, turn it off, you bastard. All right, so here we go. Radio galaxies. So what's interesting is that there are some galaxies that are bright at radio wavelengths. Now, what the hell is that about? I wonder what that is. Now, when I say I wonder, I already know, but I'm saying I wonder. Hey, Cyanide! Alrighty, Cyanide is one of our top Patreon guests. I'm dedicating this to Cyanide and to Scott and all my Patreon guests, of course, everyone. Alright, so galaxies discovered which are very bright at radio wavelengths. Hey, Abyss. Seyfert galaxies. Okay, it sort of sounds like say fart. I'm only here for the honorary degree. You know, you're so quiet, I actually forget how smart you are. That's so funny. Too good. Oh, that coffee is too good, guys. It's like, it's got that thick layer of pudding on top. And that is not a dirty joke at all. Oh, actually, it's really strong. Shit, I didn't boil it enough because I was too excited. Oh, still good. All right, what's interesting about radio galaxies? See, we as humans think we favor electromagnetic visible light over other forms of light that's not visible, right? So like infrared, ultraviolet, gamma, X, radio waves, microwaves. Microwaves we sort of think because we use them. They are popular in the Middle East. Yes, they are Greek or Middle East or Turkish. Basically, as I like to joke about on Gabsmacked, all the countries that hate each other all drink the same coffee, which I just think is hilarious. All right, so what we got here, right, is radio galaxies. So if we look at them, we can't see them, but when we use radios as our eyes, we can see them. Okay, now radio emission sometimes associated with Seyfert type galaxies, unusual spiral galaxies with very, very bright cores. And they can vary 50% in a few months. Could burn your fingers. Oh yeah, no, that's true. Yeah, you got to hold it at the top. Yeah, it could burn your fingers. These radio galaxies, 50% in a few months. So why is that happening? How the hell do these things vary 50% in a few months? Now we're going to talk about. That's why the top has lips. That's right. You touch the lips. Got to have a delicate grip. Yeah, delicate grip on those lips, my friend. Astronomy is the worst subject in the world. Oh, God. All right, so taking a spectrum of light from a normal galaxy. Now, Abyss is an expert, as far as I know, on spectra, by the way. All right, so the light from the galaxy should be mostly starlight and should thus contain many absorption lights corresponding to the stellar spectra. Part of what you love about it. I love that photo of you guys, by the way. But light from the... Oh, crap, got to blow my nose. I'm sorry. Excuse me, let me get out of the way. What time is it there? Here? Ooh, I don't even know. It is the future. It is 10:30 a.m. Sunday. Actually, I should just quickly show you my grandfather. He passed away a long time ago, but he was in the militia in the working for the Lebanese government. I'm no expert. There he is there. So his name was also Gabriel. Back to the Future. All right. So Abyss is not actually an expert. He's just very good. I've known him for a little while now. 10:30 a.m. Where it could be Grandpa Gab. that's right. Yeah, Grandpa Gab. It could be Sydney, Australia, Brisbane, or other. There's a few other smaller ones, or it could be Japan, or it could be parts of Russia, of Eastern Russia, not far from Alaska. So maybe I should talk like this because I am from Russia. I like to... Anyway, I have a dirty joke about that. All right. The light from the galaxy but light from safer galaxies have very broad emission lines. They have rapid rotation of a accreting disk. You know what that means? They have a rapid... We love dirty jokes. You were born in the Soviet Union. No way. Dirty. You just love all the jokes, my dear. Rapid rotation of accreting disk. Why is it that this galaxy Captain Deltron, speaking of Patreon members, you are good looking and smart, are you single? Thank you. Yes, I am single. You are in Australia. It's a bit, oh yes, born in the USSR. Yep. All right, so rapid rotation. Why is the galaxy rotating? Right, it's very, very quickly. Well, it must be because it has a supermassive black hole in the center. Supermassive black hole, and it's rotating like crazy, and so there's an accretion disk, and you guys know this, right? And when you have something spinning, give me a follow. Awesome she-wolf. No worries. Why do we spin? Yay, awesome she-wolf. All right, done. Keep our house. GoFundMe. Cool. Alrighty, so interacting galaxies. We spin because we like fun. Yeah, I think so. Interacting galaxies. It's the spin because, well, I don't know, in my limited knowledge, it's when you have matter being sucked towards it, and it's never ever sucked directly, right? Right, so it's like when water goes down a bathtub, you end up getting that spin, and it's obviously for a different reason, but the more that it, absorbs, it gets more and more condensed, and then that causes the spin to rotate even faster. Direct sucking. Active galaxies are this. I'm telling you, astronomy is the worst subject that can scope the stars. That's an awesome idea. Yeah, I don't really, if anyone shares stuff with me, I stop following them. And that's not because of you guys in particular. Someone got upset with me the other day because I stopped following them. And I stopped following everyone because everyone shares, and then all my people in my group get the shits. Acting so dizzy nowadays. That's so true. Especially in the US, right? Active galaxies, no, that's not true. It's the whole world. Active galaxies are often associated with interacting galaxies, possibly the result of recent galaxy mergers. That is so insane. All right, so why do these active galaxies have such a fertile nucleus? Because they are the product of lots of interacting galaxies. I'm not even making this up. The whole world is one big orgy. The whole universe, man. Maybe there is a God and it was just really horny. I share all kinds of craziness. I don't dare get mad at people. No, well, you're too kind, my dear. But as long as everyone knows the reason, but that's fine. What's happening right now? We don't even know. We're talking like 5 different things at once. Cosmic jets and radio lobes. All right. Many active galaxies show powerful radio jets. Right? Why do things always go downhill when I show up? You're just a disaster. All right. Many active galaxies show powerful radio jets. All right, the hotspot is a jet. Okay, and the jets move almost at the speed of light. That is ridiculous, right? These galaxies are spewing out a jet. They're spewing out champagne showers from their hotspot at the speed of light. I'm not going to get through this lecture at this. All right, so what you can see these extra hotspots, which are the jets. Dark angle radio tonight. All right, radio galaxies. So Cygnus A is actually A giant pair of radio jets, orgasm. Yes, I think we were alluding to that. It has always been perplexing. Yeah, so jet visible in radio X-rays show bright spots in similar locations. It's angel, not angle. Teen anal. Ah, Teen anal's back. Man, you are trolling everyone. All right, Centaurus A. Centaurus A, NGC. All right, infrared image reveals warm gas near the nucleus. All right. Radio galaxies. Jet visible in radio X-ray show bright spots in similar locations. I reckon that's something to do with a quasar. That's my thinking. All right, evidence for the galaxy moving through intergalactic material. Recent galaxy merger. Because there's two nuclei. Right? Why would a galaxy have two nuclei? It doesn't fit. Right? Two nuclei don't fit. All right. So the reason it doesn't fit is because there must have been two galaxies that merged. Daddy! It's my brother. Just came in. We have two nuclei. I think men do. Radio galaxies. All right. Member of a chain of galaxies. Twisted jets, probably because two galactic nuclei are orbiting each other. So not only do these galaxies merge and have two nuclei, but the nuclei are like rotating, because after they hit, they smack, and then the nuclei just keep going around each other like this. You can tell I love smart guys. Nobody understands. You know, your icon makes it funnier. Maybe I should go migrate to YouTube or something. All right. So twisted jets, probably because two galactic nuclei are orbiting each other. All right, that's radio galaxies. Formation of radio jets. Twisted magnetic field in the jet. Jets are powered by accretion of matter onto a supermassive black hole. All right, well, we know that. So when things get sucked into a black hole, right, they spin faster and faster, 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 and then they just blast out this energy, right? And that energy turns into a jet. And this is what happens. It runs at 90 degrees to the accretion disk. So the matter is flying around this plug, and then it just goes and just blows out the the top and bottom. Right? The powerful radio lobes, they're called radio lobes because they have the lobes. Right. They can push away intergalactic gas in galaxy clusters. Kind of like a fan. Yeah. Like a jet fan, like a plane that has its jets the wrong way. But they aren't flat. No, they're not flat. Even hundreds of millions of years after the galaxy's activity has calmed down, there are still ghost cavities in the X-ray emission from intergalactic gas. So even after the champagne shower, there's still evidence of it. You know, a very long time later. So I'm going to put the highlights of this on YouTube now. I've decided I'm going to start doing that. Like a turbo with areas of low pressure. Yes, that's a long one. That's a All right, let's talk about quasars. Do you take astronomy class? Yes, I take astronomy class, but I have to do it to do my degree, even though I knew this stuff as a kid. Active nuclear. Oh, by the way, cyanide, I had to tell you, it should be something like a scrambled information of entangled particles. I would say that Abyss, you are dead on, and once again, I don't think anyone else gets what you're talking about. A secret Einstein-Rosen bridges. Also called Serb, like Serbian. Haha, hilarious. All right, so there's a new show on ABC called The Good Doctor, and obviously they're going to ruin it, but that is exactly the gab. I looked at it, I thought they stole my life and put it into, yes, that's what I was saying, into quarks, yeah. Active nuclei and elliptical galaxies with even more powerful central sources than safer galaxies. All right, so also show strong variability over timescales of a few months. Very strong broad emission lines in their spectra. So that's going to be us, basically, when we merge with Andromeda. The Good Doctor, yeah. I was so pissed. I'm like, why are they using a fake person? Come and film the gab, my friends. Like, that's my book. Anyway. Someone must have bought my book and made the show. The Spectra of Quasars. And when uni finishes in 3 weeks, I'm going to go sell the book. Yeah, well, that's the plan. I'm going to go sell them the book. Sell them. That's my plan. I'm going to walk up to ABC. Spectral lines show a large redshift. There's a huge redshift in a quasar, right? Huge redshift. Now, what does that mean? For those of you who aren't sure, yeah, probably. For those of you who aren't sure about the redshift, Abyss is like a walking encyclopedia, man. All right, I love it. So, I mean, most of you know, right? But when you have a car that's flying away from you, right, the noise drops, right? So it's like, you know, and that moving away from you, that's in terms of galaxies, that's called a redshift. So the galaxy shifts in color. Doppler, exactly. You're an info hoarder. I like that, info hoarder. We should make a new T-shirt. I'm an info hoarder. Damn, I'm gonna make that shirt now. It's the next one. All right. So it's just the Doppler, exactly. So, and the Doppler effect, the galactical version of that is the redshift. Now, the redshift happens with quasars. So quasars are like moving away at like a fraction of the speed of light, which is ridiculous. Nothing moves at that speed, right? Almost nothing, right? That actually weighs anything. And a quasar is obviously massively heavy. Frequency of light, exactly. And that's called the redshift. Exactly right. Right? Now, what's interesting is that there's a huge redshift. There's like a 16% redshift, right, when it comes to quasars. And you got to realize that, like, for example, if I'm moving away from you, the redshift is like a billionth of a billionth of a billionth of a percent, like a nothing, right? I'm just making up the number, but it's a nothing. This is 16%, right? So you're talking billions of, millions and billions of times, massive. So it's like, imagine if the Formula One race car was like traveling at like, 20% the speed of light. So just to give you an idea, if you could travel at the speed of light, you would do a lap around the Earth at the equator. They are exceptionally, exactly, yes. You would do a lap around the equator at 1.4 times in 1 second. You could travel at 20% the speed of light. You're going 1.4 times around the Earth in 1 second. It shows you how fast you're going, right? So you're like, this. Anyway, so studying quasars, right? What's brilliant about them is because, like what Abyss said, if you vibrate at the speed of light, what happens? You can't. It's impossible. But good question, because at the speed of light, there's no such thing as time. The study of redshift investigate questions. All right. Maybe you'd glow. Where am I? All right, so as Abyss was saying, they're one of the brightest things in the universe, and that's really good because they're so freaking far away, right? But they're so far away, lucky that they're bright, so we can actually see what's going on. So it allows us to see the limits of the universe because it's sort of like they're a torch really, really far away, so you know that we're at least that big. Then yeah, that would make sense. Of Yime. You know what's funny how obsessed we are with spelling? Dr. Sexy is back. Got to hear your voice, Dr. Sexty. 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 By the way, if anyone hasn't heard Dr. Sexy's voice, that was the first time I've heard it. Hey, better to be high than low, I guess. Yeah, I heard it for the first time, actually. And I have a feeling that her periscopes are going to get thousands of followers. Many of them men, I would say. Because she knows she has a voice that was born to be heard. You'd probably need big breaks to stop vibrating. All right, early history of the universe, galaxy evolution, and dark matter. All of those we can use quasars to figure out. Double-lobed jet structure, okay, and this is the quasar, right, down on fleek. So you can see here, right, it's got the jets coming out. Hey, welcome back, Awesome Wolf, Ernie Banks, Bose, everyone's coming back. So here we are. You can see that it's just blasting out crap. So just it's ridiculous. It's ridiculous how fast they're going. So, Posh Whisper, hello. Minor quark in the system. These things are going so fast. These things are going so fast that if you lived on one of these, right, your life right? By the time you were like 80 years old, everyone on Earth would have been dead for like 3 or 4 generations at least, because time is so slow at these things, right? And it's a very, very difficult concept when it comes to the universe, because the universe in 3 dimensions is infinite as far as we know, but in 4 dimensions it's finite. So because we get confused, we don't realize that we live in a 4-dimensional universe. And so what happens is that there is an end to time itself as opposed to an end to the space, right? So it's a 4-dimensional object, yeah. And so the only way to get to what you would call the edge of the universe is to go outside of time itself, which makes no sense. You can't do that if you, hey, Boss Briggs, you wish you could perceive the fourth. Yeah, the only way I see it is in mathematics. Like when I'm doing the equations, I can see it, but I can't, I can't. Like the sands from an hourglass, pretty much, yeah. I speak about it, build a TARDIS. Cyanide, this is when you let your IQ slip out. All right, so other types of AGN and AGN unification. Quasar, right? Properties very similar to quasars, but no emission lines. So these are the BLLACs. How dare you? Emission from the jets, teen anal, woohoo! Emission from the jet pointing towards us is enhanced compared to the jet moving in another direction, which we call the counter jet. Right, so the AGN unification. So this is pretty crazy. This is how the jet system is working, right? This is a breakdown, a 3D model of how the jet system is working. All right, so you can see here that that is the galaxy, and this is the jet spewing out the side, and that's in the center is the supermassive black hole. That's billions of times the mass of the sun. So it's spewing out these particles, right, in the form of X-rays, which is just blasting this thing as a jet. So that's how future spaceships will be built, you know, using stuff like that. You could have like a thermonuclear reactor at the core, which, like, I don't know, shoots out particles. Bursts of activity of supermassive black holes. A star wandering too close to a supermassive black hole can be disrupted and trigger an X-ray outburst, which is pretty awesome. So, you know, you have the black hole that you can't see. It's like a trap, right? And then there's this star just wandering along. Hello, I'm a star. And then it gets sucked in. And it's like, whoa, whoa, whoa. And as it gets sucked in, it gets ripped apart. It's like, you know, and then it splits out into a light beam. And then it goes in, it goes in, it goes in. And then massive explosion. When they interact with a gas in intergalactic space or another galaxy. Exactly. Abyss, by the way, it's like a huge fart. Yes, a huge fart from a teen anal. Abyss is my co-host, by the way, everybody. Bursts of activity of supermassive black holes. So gallery of quasar host galaxies. So we can see these, right? Now what I'm going to show you is in the past. In fact, it's 12 billion years in the past, right? So you're looking back in time. Hostages, or hot gases. Hot gases and hostages, same deal. So there you go. So those things there, okay. Okay. Are you talking about Star Wars? Possibly soon. I think once the Earth becomes one country, we'll start colonizing planets and we'll have more Star Wars. There is claims Star Wars might even be real. There is claims. That's amazing. A guy from Sunday showing me past on Saturday. That's right. Bose is like thinking like multi-dimensional, sucking in and vomits. All right. So basically there aren't as many. Trolls are hilarious. They just walk in and step on people. All right. So what we got here is this shows you what type of quasars we had at what time. And the Bible is all Star Wars in different wording. Interesting way to look at things. You never know. It could all be true. I'd love to see you argue that with a Christian. Oh, that would be so much fun. Oh, that would be so much fun on Irrational. I'd love to see that. All right, so you can see that quasars at this point in the universe's history early on were heaps. And now Irrational. That's an awesome channel. All right, and now there's not that many. So there were heaps at the beginning, and now there aren't that many. Those Bible thumpers are too much at times. You're right. I prefer the Star Wars thumpers. They're much better. Can I join that religious discussion? It would be a lot of fun, Dr. Sexy. In fact, I'm gonna have to do that. Hey, Lady Raincorn, long time. One of my first ever followers 5 months ago when I had like 3 followers. Hey, long time. All right. Religion divides people and Star Wars unites them. What is the moderation doing? So are you a scientist? I am a scientist. I like that. How are you doing? Great. I'm great. I have all my beautiful people here. It's a lot of fun. Now, the last thing we're going to talk about is this stuff. All right. Where are you from? I am from Australia. If you go to YouTube to Gab Smacked, you should do a live call-in show. I should, actually. Saying the aliens are real. Aliens are real. Aliens are real. All right. So that's going to be the end of this one. The next one's going to be more, as in a science test. The next one will be more mathematics, unless you guys want to do it now. But I have a feeling that most people are too high to do mathematics right now. But I still have some coffee left, which really annoys me. So I haven't finished the lecture. Okay. Well, there's a few things left, and then we'll do the mathematics. All right, most people who study astrophysics are mean. Thank you for meaning so kind. You are a good play on words. The force is strong in this one. Scott says, let's do the maths. If Scott says it, I'm probably going to do it. It's really, really basic maths. It's only high school maths. So, okay. Basically, all right, so here's the first question, right? Get your pens and papers ready. Let's do it. Break the math. All right, so you ready? So get your pens and papers and let's begin. Awesome, creamy excellence, I love that. This coffee had creamy excellence when I just realized that's another bad joke. All right, if a star has a surface temperature of 20,000 Kelvin, that means 20,000 degrees above absolute zero, right? At what wavelength will it radiate the most energy? Can I share your pen and paper? Sure, let's do it. All right. If a star has a surface temperature of 20,000 Kelvin, 20,000 Kelvin, so write that one down, 20,000 Kelvin. What wavelength of light will it radiate the most energy? Okay. What wavelength of light? Okay. 4,700 Kelvin. I don't even know what a Kelvin is, but it sounds good. 2 nanoseconds. 1 gigawatts. 1.21 gigawatts. Gigawatts. All right. Hey, Doug, Marty. All right. So it is the wavelength multiplied, okay, by the temperature equals 300,000. That is the formula. The formula is that the wavelength, yeah, I know, I forget all of them, multiplied by the temperature equals 300,000. Where we're going, we don't need... No, I didn't do it well. Marty! Hey, Banter, you've changed your icon. Welcome back. I was wondering why I didn't recognize you. What is this space scope? Do you really just like outer space stuff? I just teach random stuff. Wavelength times temperature equals... It equals 300,000. Here it is, right here. That is the formula. The formula is that the wavelength by the temperature equals 300,000. It's always that, okay? So that means just using algebra, that T goes underneath. So 300,000 divided by, exactly 300,000 divided by the temperature, which is 20,000, exactly the inverse, is going to equal the wavelength, okay? So therefore... right? All you have to do is get 300,000 over 20,000 and you get the wavelength, which is 150 nanometers. Right? So that means 150 times a billionth of a meter. That's the wavelength of the light, right? And that's how you know that the temperature is 20,000 Kelvin. It's actually quite big, actually, compared to like some of them, but yeah. But compared to radio waves are like 20 centimeters, right? Which is like, well, so what's 20 centimeters? Like 8 inches. Don't ask me why I know 20 centimeters is 8 inches, all right? Do not ask me that question. Did I say 300,000? I meant to say 3 million. No, 3, 1, 2, 3, 4, 5, 6. Sorry, you're right. It's 3 million. I'm so sorry. I'm so sorry, everybody. It's 3 million, not 300,000. All right. 3 by 10 to the 6. Oh, and the reason I said 10 to the 6 and not 10 to the 8 is because we're working in nanometers. Yeah. Do you have 8 inches long? Too funny. The width is much more important than the length. Let's just 4 inches. It really depends on the size of the cavity. Let's just say that, without getting into it. You've been. Infrared observations of a star show that it is most intense. Is it just me, or is it getting really hot in it? Did you get my tweet? Not yet. I haven't looked at my tweets today. Blame it on someone else. I feel very... We've seen Gab blush. Yeah, I think so. This conversation devolved instantly. I know this is the worst lecture in history. Infrared, I mean, I keep thinking my last lecture was worse, and then the next one just gets even worse. Infrared observations of a star show that it is most intense at a wavelength of 2,000 nanometers. What's the temperature of the star's surface? All right, this is now... I'd go to this college. Yeah, I know. All right, this one here, we're just going to rearrange. So we know the wavelength. We want to know the star's surface temperature. Well, we know, once again, that the temperature in nanometers, the wavelength in nanometers is a temperature by 3 million. All right, so 3 million, but we know the wavelength. Now we want to know the temperature. So the temperature is 3 million divided by the wavelength, which is 1500 Kelvin. I doubt it. I doubt it, because my lecturers hated me, man. Ooh. How many times I got in trouble? I'd be a damn valedictorian, you would be. Oh, that's disgusting. That was like the end of the coffee. Oh, la. Oh, that's gross. Give me this pear. Yeah. I'd have to keep you away from the male students. They'll all be signing up. All right, next one. We've only got 2 more to go, I think, and then we're done. All right. Biology. The chicks will too, yeah. I just stopped by to let you know that Jesus loves you so much. Thank you very much, Yawn Music. Oh, sorry, Yawn Music. If you double the temperature of a black body, it's great that Jesus can get people to tell us on his behalf. No way. Dad doesn't make it better. I make it better. Yeah, I think Dad is slightly better, but I wouldn't tell him that. If you double the temperature of a black body, by what factor will the total energy radiated per second per square meter increase? All right. So the question is, if you double the temperature of a black body. So a black body is something that, and more jokes. Yeah, I know. This, you too, my friend. I'm so sorry for Dan on Fleek, because you know what? I'm hiding these Nah, I don't know what I'm gonna do. I'm gonna get through these 2 questions. If it kills me, I'm gonna get through them. All right. If you double the temperature of a black body, right? And a black body is something which traps radiation inside it, which is anything. It could be this, it could be an orange, right? You know, radiation goes in and then it just sort of, you know, goes around. Depends if Kanye is playing. That's right. You're not helping, Dan. All right, the amount of energy radiated per second per unit area. Okay, so each unit area of the black body per second, right? It goes up by the fourth power. Okay, the Wi-Fi is killing you. As a result, the temperature increases by a factor of 2. The energy radiated will increase by 2 to the power of 4. Okay, so if you double the temperature of a black body, then the energy radiated per second per square meter goes up to the power of 4. What's 2 to the power of 4? 2 to the power of 4 is 16. Just Simon, long time. All right, next one. Last one. This is the last one and I'm leaving. Sweet 16. Sweet 2 to the power of 4. The nebula shown below contains mostly hydrogen excited to emit photons. What kind of spectrum would you expect the nebula produce? All right. So this nebula, okay, a nebula is like a precursor to a solar system, right? It's a baby before it's born. About the 8 inches. I admit to nothing. All right. What kind of spectrum would you expect the nebula to produce? Okay, so have a look. It is hydrogen excited to emit photons. Okay, so there it is right there. That is excited to emit photons. All right, so nebula is a low density gas, right? A low density gas is excited to emit photons, is analogous to the discharge tubes we looked at in class. Oh, did we look at them in class? I get excited. With its own fingerprint or pattern of colors. This is an emission line spectrum. All right. This is called an emission line spectrum. I'm floating in your pool. That's awesome. I thought you were looking at through telescopes. You can do many things at once. All right. So basically it's emitting photons, right? And that gives us an emission line spectrum. That means that we can analyze the spectrum that comes to us, and based upon the gaps in it, we know what pixels are being occupied of the universe, so we know what material is coming from the star. And that is the end of our crash landing in astronomy. So I think it's time to leave. With white bodies, they don't seem to be important to talk about. They don't talk about them in this course. Early evolved Adilla. Right back at you. 1, 2, 3, crunch. Jam bodies. How many? All right, guys. Facts don't care about our feelings. Does anyone want to see Pompous before I go? Always a pleasure, Abyss. I'll be back. Hey, come here, come here. Come here. No, I don't want to. Come in. No, damn it. I don't want to be here. What are all these losers doing here? They're not losers, they're listening to my scope. Exactly, that's why they're losers. Where have you been? I don't know. You wake me up, it's the middle of the day. It's so hot too. What do you want, you bitches? I don't know what else to say. You made coffee, did you? Yeah, I did. Did it suck? No, it was awesome. I bet you your dad's is better. I'm still tired. This is so annoying.
Everybody, go fact yourselves. Cranky, I'm just pompous. He is cranky. No, I'm not. Take that back, you bitch.